Welcome back to the channel. So the last time we finished up the crosshead guides. So today we're going to start on the crank. We've already got the shaft made here, but we're going to work on the web for the end of the crank here. So I've got a chunk of steel here out of the scrap bin that I've cleaned up on the lathe, and then I've put some dicom on the end here because we want these, we're going to lay this out. I'm going to go over how I laid it out, but we want these layout lines to be visible, and I don't want them coming off with cutting fluid. So instead of using a Sharpie or something, I went ahead and used dicom on this. So to lay this out, I put it on the surface plate here, and then the first thing I did is I measured this so that I know what the OD of this piece is. It's just a random diameter that's a little bit bigger than what we need. I haven't turned it down to size yet. And then I took our height gauge here and got a measurement for the top of the cylinder. So we know what the top measures, and then we know what the diameter is. So then I took off half of the diameter, set the height gauge here, and then I made a scribe mark on the end. So then I rotated it .90 degrees, lined it up with the square, lined up our mark that we made, and then I made another mark. So that gives us these marks here, which are 90 degrees apart and going through the center of our cylinder. So the next thing, while I was still in this orientation here, is we know that our stroke is a ½ inch up from the center. We know that this mark here is ½ inch up. So I added ½ inch to this measurement and made another mark. So where these marks cross in the center, I made a punch mark, and where they cross in the top, I made a punch mark. Which you can do that just by visually looking at it, or what I used was an optical punch set. So this has a magnifier that you can look through, and you can line up the crosshairs, and then you pull that, put this in here, look through it. Once you get the crosshairs lined up, pull this piece out, and then we put our punch in there and make a punch mark. So we pull that piece out, and then stick the punch in there, tap it with a hammer, and make a punch mark. And this does a really good job for doing accurate layout for lining up marks. So once we had those two lines, and then our line up here and our two punch marks, we know that the web of the crankshaft, it gives us the measurement for where this mark intersects this mark, and that's 15/16 wide. So we rotated it again, and then from our center measurement, we went up half of 15/16 and down. We made two more lines so that we know how wide the web is. So after that, I took and set these to the radius, and then we scribed a line down here on the bottom between these two marks that are 15/16 apart, so that we know how wide our web is, and then what the diameter of it's going to be. And then we did the same thing up here. We know that this is a 5/32 radius, so I scribed a circle here. So then we have this circle here, and then we have this partial circle down here. So to connect the two together, it gives us a dimension in the plans here of a 1 1/4 inch radius. So I happen to have, a long time ago, I made up some gigantic radius gauges that I just 3D printed. So it's the same shape as a normal smaller radius gauge, but I made a set of them going up to 1.5 inches all the way down to 5/8. So we got 5/8, got a 3/4, 7/8, and a 1 inch. And these are really handy, and they're not super accurate, but for doing layout on a lot of stuff, they work really good. So we know that this needs to be a 1 1/4 inch radius. So I laid this on here, and then I lined up the edge of this circle with where our 15/16 here on the web intersected this radius at the bottom, and then I scribed a 1 1/4 inch radius here on both sides. So this gives us the full layout shape of the crank web that we're after. I did this and took the time to do this layout because we will end up bandsawing most of this out once we get it cut off, and then filing it to shape. So the first thing we're going to do is set it up in the lathe, and then we're going to turn it down to this overall diameter. And then once we do that, there's a relief on the back side, so it gets to turn to a smaller diameter. So we'll take the cutoff tool and plunge it in for the width here that we need the web to be, and then plunge that into what we need the diameter to be for that relief on the back, and then we'll step over the full width and then go ahead and cut this piece off. So once we get it cut off, then we'll take it to the bandsaw, cut this shape out, do some filing on it, and then while it's in the lathe, we will bore and ream the center here where it gets pressed onto the crank. And then at some point, probably after we cut it off, before we bandsaw it out, we'll drill and tap this hole here for the bolt that holds the connecting rod on. So that's a good, accurate way to lay this out so that we can see our scribe lines good, and then we can file right to these lines. So we'll go ahead and get this set up in the lathe and start getting it cut down to size. Okay, so that went good. I got the crankshaft web pretty much finished up. So we turned it to size on the lathe, and then after we did our mark out, and then took it back out, put it in the bandsaw. Before I did that, I did cut the back here with the cutoff tool to leave this 3/8 diameter here. So then we put it in the bandsaw and cut out most of this section as close to the lines as we could. And then to put it in the bandsaw, because I did the layout on the front here and I did the relief on the back, which I debated which was the best way to do that. But to keep it from tipping over in the bandsaw when the blade grabbed it, I did take a washer, flat washer, and put it on the back here that this fit inside of, and that flat washer would hold it up so that we could bandsaw this section out. So then I did a little bit of filing work, and that's what we ended up with. So then I turned the shaft here down to be a press fit here, and then put it on the arbor press and press this into there. So after I reamed this hole, I did use gauge pins to measure it just to get a good accurate measurement on there, so I knew what to turn this shaft to for the press fit. It's about 1/2 thou to 1 thou larger than what the hole size is. we ended up at this hole ended up at 189, excuse me, 189 on the shaft. The hole's about 188 or 188 and a half, somewhere around there. So it turned out good. Still need to drill and tap this hole here, 540 for the screw, but fits in there good. You can see the clearance that was needed there that we machined out earlier for the crankshaft web. So that's all looking good. The next thing we're going to work on is the flywheel. So I'm going to make mine out of steel, and it's a 1/2 inch wide by 3 inches in diameter. And then there's options. You can do drilled out holes, or you can do spokes, or different kinds of designs there for the flywheel. I want to try to do the spoke design here. So to start with, I've got just a big chunk of metal. It's way too big. It's about 4 inches by 4 inches. So I'm going to cut it. I'm going to cut it out on the bandsaw. I'm going to lay it out, mark it out, and I'm going to cut out a 3 by 3 square to start with. Then we'll mark the center of that square, and then we're going to drill it and ream it for the 1/4 inch hole. And then take it back to the bandsaw and then cut as close to the 3 inch circle as we can. And then we'll take and mount it on an arbor and put it in the lathe, and then we'll turn it down to a 3 inch circle. So then we'll have a 3 inch circle, 1/2 inch wide, with a 1/4 inch hole in the middle of it. Then after we do that, we'll come back and do some more layout and talk about drilling these holes and getting these spokes in here. But to start with, we're just going to get a 3 inch circle with a 1/4 inch hole in the middle of it. Okay, so we got our 3 inch circle now with a 1/4 inch hole drilled and reamed in the middle. So I cut out a little bit bigger than a 3 inch by 3 inch square and the bandsaw. We drilled and reamed a 1/4 inch hole in the middle, mounted this on an arbor. Before I did that on the square, I did bandsaw off the corners so that we wasn't having to remove so much material on the lathe. Put it on an arbor, and then we turn it down. And because it is an interrupted cut, I did use a high-speed steel bit. They seem to survive a little bit better. If you're using carbide tooling with the interrupted cut, it has a tendency to want to shatter those bits. So we did use a high-speed steel bit to get that turned down. So we got that turned down to 3 inches. So the next thing we need to do is remove this material inside here. So this is relieved on both sides, and then there's a hub, 1/2 inch hub left in the middle. So what we're going to do is called trepanning. which if you watched the series on the build on the Webster engine, you've seen me do this before, but just to go over it real quick, it's basically a cutoff tool. So if you're looking at the front of it, it's got a little bit of an angle on it. It's just like a normal cutoff tool would have. A little bit of angle on the front. So it would be like a normal cutoff tool that we're going to plunge into here, but because this is circular, instead of being just at an angle, you've got to have a relief, you got to have a radius on both sides. This is exaggerated, but looking at the end of it, this is what it would look like. From the front, it would still look the same with a relief angle on the front. So you can see the tool here that I have. It has a radius to it on the inside and on the outside here. And then it's just a normal cutoff tool. So we'll use this to plunge into here and then relieve material out. Once we get so far, then we can use a regular turning tool and turn a lot of this off with that. But to get started, to plunge into here, we use the Trepanning tool, and we'll do the same thing on both sides. And then once we get that material relieved, then we're going to come back and on a 1-inch radius circle here, we've got some 3/16. We'll drill 6 holes here for the inside of the spokes. And then we'll drill 12 holes here on a 1-inch. This is on a 1-inch radius here. We'll drill, this is a 7/16 radius here. This is a 1-inch radius here. So on the 1-inch radius, we have some 1/8" drill in the corner here of the webs. So we'll drill 12 of those. And then to remove this material, ideally you would use a rotary table on a milling machine, but since we're trying to just do this entirely with a lathe and a drill press, I'm probably going to chain drill this on the outside. So once we get set up, we'll drill and then step over, drill another hole, step over, drill another hole. We'll drill this series of holes out here. And then I'm planning on leaving these here on the straight sections and then taking the Dremel with a cutoff tool and cutting these straight sections here. And then I will do some filing, do lots of filing work, and then we'll get this cleaned up and get these sections removed here for the spokes. But the first thing we'll do, get it in the lathe and get this center section here worked out on both sides. Okay, so I got the flywheel here machined out on both sides. So we used the trepanning tool and went in here and put a groove on both sides, and then I did each side a little bit different just to show two different methods. The first side, after I got the groove in there, then I worked out this whole center section with a variety of tools. Turning tool, I turned some of this off, and I used a round nose tool to carve some of it out, and then a 45-degree tool to work a little bit more of it out. And then once I got that worked out, then I used some boring bars and kept machining in here until we got this machined down to the 1/2 inch, and then machined back this section out here. On the other side, I just used the trepanning tool for the whole thing. So we did the first groove and then stepped over about 40 thousandths and then cut another groove to depth, and then I left it a few thousandths shy. So I kept working that all the way down till we got this down to 1/2 inch, and then I plunged in a couple of thou and then cleaned all this up and worked my way back across to try to get rid of some of the steps that you can see from the different cuts. So trepanning the whole thing out, I think, is easier and works better, but I tried it both ways just to show that there is a couple of different ways to get that section machined out. So next thing we need to do is drill these holes. So on the 7/16 radius, we have 6 holes on the inside here. That's a 3/16 drill. And then we have 12 holes on the outside on a 1 inch radius. That's 1/8 inch holes. So the 6 on the inside will be pretty easy because they're going to be 60 degrees apart. The holes on the outside are at a different angle. So I drew this up in CAD just to figure out what the angles was going to be. So there's 18 degrees between the 2 holes that are closest to each other, and then the next set of holes is 42 degrees apart from that. So I've got this mounted on an arbor. So this is an expanded arbor. It's a 1/4 inch that you can stick in there, and then there's a screw here on the end that when you tighten this up, it expands this. So this arbor will hold this. And then we're going to put this in a 3-jaw chuck on the rotary table to drill these holes. So I've got the rotary table centered, and then we'll step over for the radius, and then I've got it zeroed out. So we'll do our first set of holes for the inner holes: 0, 60, 120, 180, 240, and 300. And then once we drill those holes, then we'll step over for the 1 inch radius, and then we'll drill these. These are an 1/8 inch hole, and then we'll drill these. I've got it laid out starting from the same 0, 21, 39, 81, 99. So we'll go around and drill those holes. And then to work the section between these, if you was doing this with a milling machine, then I would mill this section out with an end mill or something on the rotary table. But since we're doing this with just a lathe and a drill press, I'm going to chain drill a series of holes between these 2 holes here. So we'll drill, step over, drill, and just leave a little bit of material between them. And then we'll go back with a cutoff tool and cut that section out. And then we'll clean all that up with a file. And then the same thing here on these straight sections. We're going to cut this out with a cutoff tool on the Dremel. And then we'll go back in, and then we'll blend all this together and clean it all up with the file. So we'll get it set up in the rotary table and start getting all these holes drilled. Okay, so we got the flywheel finished up now. That was a lot of cutting. So put it in the rotary table, and then we drilled these 6 holes on the inside here first, and it started to turn with me just a little bit on that arbor, so I ended up just putting it directly into the 3-jaw chuck, which is what I should have done to start with. So we got those 6 holes drilled, and then we drilled these 12 holes here in the corners, the 1/8 inch. So drilled all 12 of those, and then in between here I chain drilled a series of holes. I went down a size on the drill bit, because if the drill wanders a little bit, then I still want to be able to clean up this edge here to where it needs to be and try to get rid of all the drill marks. So I went down a size, stayed on the same radius, but went down a size in the drill bits. Then I was able to drill every 7 degrees between these 2 spots in all 6 sections. Then after that, I tried cutting this out with a cutoff tool with a Dremel, but it's just too far down in there to try to get to it to cut it. So I figured out that a 1/2 inch drill bit, I could drill in between these webs, and then it would come real close to breaking through where this hole was drilled, where these series of holes was drilled here. So I went back and drilled 6 1/2 inch holes, 60 degrees apart all the way around here. So then I got the majority of the material out, and then after that I took it to my die filer, which is not really a die filer, it's a scroll saw that I've made into a die filer. But if you look at the old literature and the old manuals for scroll saws, they actually showed you using files and using various tools other than the saw blade with those. But I have adapted a hacksaw blade to go into my die filer, so I was able to come into here and just cut out these little corner sections here that was left from the 1/2 inch drill. So after that, I put some files in the die filer and just started working this down, working down the straight sections here, and then working down this curved section, and then put it in the vise, and then with hand files did a lot more filing, and then put a stone on the Dremel and went at it with a stone, and then eventually went to some sanding discs on the Dremel and then cleaned all this up. So it's not perfect, but it turned out pretty good. I think it'll work good for what we're doing. So let's see what it looks like. So I think that's going to work good. So we'll still have to put some, I think there's some spacers that goes in here, and then we will have to drill this at an angle, and then tap it for a 3/48 for a set screw, and we'll clamp it to the crankshaft. So we'll do that. We'll get that done, get the set screw put in there, and get it attached to the crankshaft. So that's going to do it for this episode. Thanks for watching. Come back next time. We're going to go ahead and drill the hole in this crankshaft, and then we're going to make this crankshaft screw here. Go ahead and get that done. But the main thing we're going to do, now that we sort of got everything located already, is we're going to machine these sides here and here, top and bottom, all the way around to that 5-degree angle. So it gets a 5-degree taper on all the sides, except for where the bearings mount to. So we'll get that set up and start machining it on next time. Thanks for watching.